Hello friends, welcome to TechCube classes. My name is Professor Vivek Singh Rathore and I am teaching you Signals and System subject. Signal and System subject we have come across module number 6 in the lecture number 2. That will be 37th lecture. Okay. So till now we have studied all 5 modules in that Laplace transform have been completed, and in this module we are studying Z transform. Okay, Z transform is a generalized transform for discrete time signals, and in the last lecture I have told you what is Z plane, introduction, how it came from discrete time Fourier transform to Z transform, and then we have seen some of the standard signal Z transform. So in this series we'll move further and we'll see what are some properties of Z transform. So moving on, we'll see the first property, that multiplication by multiplication by a, okay, or you say an exponential function. Okay, we can say exponential function. Okay, fine. So as you know that f of n is there, its Z transform will cause it f of z will be there. Okay, f of z will be there. Okay, you can write here like this, f of z. Okay, now if you multiply a to the power n into f of n, what will happen? If you'll see, wherever z portion was there, you can replace by z by a. Whatever a may be there, you just have to divide z by z. You have to replace z by z by a. Okay, and what will be the effect of ROC in ROC? So see, here ROC may be real part of S. Okay, here ROC will be real part of S, or you can say mod of Z. Okay, here we can say that ROC will be S by A, or you can say that mod of Z by A. Okay, so see, this variation will happen when we multiply exponential function. Let's take some example. Okay, let's suppose u of n is there. U of n, its Z transform is 1 by 1 minus Z inverse is there. Okay, and ROC is mod Z is greater than 1. If we multiply a n u of n, what will happen? According to property, wherever z is there, you need to replace z by a. Okay, z by a inverse. Okay, so this you can write that z 1 minus 1 by you can write it as a by z also, and here it can be written as z by z minus a also. Here also that can be written, and earlier this was mod z is greater than 1. Here mod z by a is greater than 1. This replies that mod z is greater than a. Okay, so this will be the ROC. Very simple property, nothing is there. Just if we multiply exponential function, so there will be a variation in z. It will wherever z will be there, it will be replaced by z by a, and ROC will be also replaced by z by a. So I have seen I have done one question also, you can understand it. Okay, now using this property we'll see how we can check causality and stability from ROC of Z transform. So let's take some example. See, 2 to the power n, if you multiply with u of n, what will happen? See, now only we have seen the property. You can tell me that sir, u of n is 1 by 1 minus z inverse. Okay, and a to the power n u of n is nothing but z by z minus a. So here it will be z by z minus 2, obviously, and the ROC will be C, mod z is greater than a. Okay, so mod z is greater than a, so mod z will be greater than 2. Okay, so we can plot this ROC. If we'll plot this ROC, Okay, let's suppose this is a unit circle. So see, ROC will be mod z is greater than 2. So let's suppose some two values there. Okay, 2 radius 2 circle is there, and now the ROC will be this value. Okay, so this value is there in the outside. Okay, outside is there. Is it touching the r is equal to 1 circle? R is equal to 1 circle? No, it is not touching r is equal to 1 circle. Therefore, we can say that it is not stable. It is not stable. Okay, it means that it is not absolutely integrable. Okay, it is not absolutely integrable. So see, I have told you earlier also, in the last lecture also, I have told you in the introduction of Z transform that whenever the region of convergence is involving the radius is equal to one circle, unit circle, then it is absolutely integrable signal. And then you can say that it is a stable. And then you can tell that this signal will have Fourier transform will have, because see, I told you that Fourier transform is a specific condition, or you can say specific version of the more generalized transform Laplace or Z. Z is in discrete domain. So in discrete time Fourier transform, that is DTFT, is possible only when the signal is stable, the signal is absolutely integrable, or ROC is involving the R is equal to 1 circle. So it is as I can write as ROC does not include R is equal to 1 circle, therefore it is not stable, therefore it is not absolutely integrable, therefore DTFT of this is not possible. DTFT is not possible. This all condition you should understand. You should not memorize that okay, it is not absolute, it is not possible, it is not possible. Why it is not possible? You should understand. Now I'll see one more question is there. Let's suppose half to the power n u of n is there. Okay, now you have been asked to find the Z transform. As you know the property that any signal a to the power n u of n is there, then its Z transform will be Z by Z minus a with the mod Z is greater than a. है ना, ये this you know. So here will be half Z, sorry, 1 minute, it will be okay, Z minus half will be there, and here mod Z is greater than half. Let's plot its ROC. So let's suppose this is unit circle. Now this is let's suppose this is half radius half circle. This is half radius circle. Now ROC is greater than half. So this value is increasing. Okay. So is it including the j omega axis? Yes, it is including the j omega axis. So as ROC is including j omega axis, therefore signal is, it is absolutely integrable. First of all, absolutely stable. Okay, for stability also it is not j omega axis, it is r is equal to 1 circle, that is unit circle. Unit circle we can write it as ROC is including r is equal to 1 circle or unit circle. It is absolutely integrable, it is absolutely stable, and DTFT is possible. DTFT is possible. Okay, when we can take DTFT whenever this unit circle is included in the ROC. And how we can take DTFT? Just putting Z is equal to e to the power j omega. Z is equal to e to, because see, DTFT is possible. DTFT is a condition. See, earlier Z is equal to r e to the power j omega was there, but DTFT is when possible? When your r is equal to one circle is included, है ना? So r is equal to one circle will be included, then only it will DTFT is possible. So DTFT is a particular condition of a more generalized transform Z transform. So we'll take r is equal to 1, है ना? Whenever we'll need to take DTFT, and so here r is equal to 1 we have kept, so z is equal to e to the power j omega, so you can directly put the value, z is there, so e to the power j omega is there, e to the power j omega minus half is there. This is actually what was your signal? Your signal is half of n, half of n u of n, half of n u of n. Its DTFT is like this. So now you can understand that how we are seeing the, and DTFT is will not have any ROC because it is unique value only. We are taking ROC because so many values are coming, so we need to identify that with the region of convergence value. So see, now you understood, I think you have understood that how to take how to multiply exponential function with your signal, and then how it is affecting the ROC, and from ROC we can understand that if it is involving the r is equal to one circle, then what will happen? If it will not involve, then what will happen? And if it will involve, then DTFT is possible. And how we can take DTFT? By just putting z is equal to e to the power j omega. See, now I told you analysis. Now see, earlier also from question only you can say that it will be like this or not. See, this portion is there, this question was there, 2 to the power n u of n is there. So this signal, if you plot this type of signal, what will happen? See, if you plot this type of signal, 2 to the power n, and 2 to the power n u of n. So n is equal to 0 means u of n is there. So u of 1 will be like this. I'll do like this. Okay. Okay. 2 to the power 1 u of n, 2 to the power 1 u of n, 2 to the power 2 u of n, 2 to the power 3 u of n. It will go on, go on, go on, go on. Is it absolutely integrable signal? No. That is why it is here we have written not absolutely integrable. From ROC also we have seen that in the frequency domain, and from time also we can see that the signal is not absolutely integrable. We'll check this also. Half n un is there. Okay. So if we'll plot this half n un, what will happen? Half n, half 0 u of n. Okay. So we'll plot like this. Okay. This value is there for n 0 to 0. Then half, then 1 by 4, then like this, like this, like this, like this, and so on. It will go on like this. It will go on to 0. Is it the signal is absolutely integrable? Obviously it is absolutely integrable. That is why it is this from ROC also we can see it is absolutely stable. DTFT is possible. That is why this only I wanted to tell you, that from signal also you can understand what we are understanding. From ROC also we can correlate both signals. Okay. So see, I think the basic function you understood, that if your ROC is involving r is equal to one circle, unit circle, then definitely the signal is stable, absolutely integrable, DTFT is possible. 3 all you should remember. Okay. And if it is not involving, then all conditions are not satisfied. Now we'll see condition for causality. Okay, condition for causality. Okay, fine. Causality signal. Okay. So see, for causal signal, you need to understand that h of t should be equal to 0 for t is less than 0. It means that your impulse response should be, or whatever your signal may be, it should be signal, ठीक है, yeah, impulse response. If you write impulse response should be right sided, है ना? Because see, its main condition is that it should be 0 where for t is less than 0, means it should not occur in this side. this side should not occur. It will occur only in the after t is equal to 0. After t is equal to 0 only, if a signal or impulse response is existing, then only we can say that that is causal. Yeah. Now see how we'll see it. And if signal is should be right sided, therefore from if from ROC we need to conclude that signal is causal or not. ROC should also be outward from unit circle. This is the condition for causality. In time domain also I told you, and from ROC also I told you. Let's suppose we'll take see here only we'll understand this, that this signal, okay, both signals were 2 to the power n u of n, value is this, okay, this is causal only. Half to the power n u of n, this is also outward only, so this is also causal only, okay. Okay, we should not tell that ROC should also be outward from unit circle. Actually, for causal, ROC should be outward only. Should be outward only. But I'll tell you when we'll consider unit circle. See, I'll give you one more example. One more example, like minus 2 to the power n u of minus n minus 1 will be there. Okay, 2 to the power n u minus u of minus n minus 1 will be there. So then what will be happen? See, as you know that minus a to the power n. See, minus u minus n minus 1. Z transform, as you know that it is z by z minus 1 is there, okay. And if you will multiply 2 to the power n, then what will happen? Just z by 2 will come, z by 2 will be there here, so here will be z by z minus 2, okay. And the mod z value will be equal to is less than 1, is less than 1 because it is left side signal. So here also mod z by 2 will happen, is less than 1, so mod z is less than 2, okay. So see, now what will happen, we'll draw its ROC. This is, let's suppose this is unit circle, r is equal to 1 circle, okay. And see, the poles are mod z, region of convergence mod z is less than 2, so here we'll make a circle of radius r is equal to 2, and we'll see it should be less than 2, so ROC will be less than 2, means we'll plot like this, okay, we'll plot like this. So now you can tell me, or directly plot this signal in time domain. What you will get? See, you will get first of all, it is in the left hand side signal, u of minus n minus 1 will be there, and this signal will be, see, 2 to the power n, value will be ranging from minus 1 to infinite, so it will value will be like this, okay. Then it will go like this, and it will go like this, and it will go like this, and it will like this, it will go on like this. So is it absolutely integrable? Obviously the value is tending to 0, right? So this is absolutely integrable. This means that it is absolutely integrable, and if it is absolutely integrable, what we can suggest, that it is a stable, and we can say that DTFT is possible, okay. And again, now we can say from causal that the ROC is outward, the ROC is inward, and it is ROC is inward, okay. So can we say that it is a causal system? So we cannot say it is a causal system. So we cannot say it is a causal system, because for causal the ROC should be outward, and here ROC is inward. That is why we cannot, and as see, in time domain only it is existing from n is equal to 0 in the left hand side. So obviously it is not causal only. From time domain only you can say, but from ROC also you can say that ROC is invert, so it is not causal, but it is stable because it is involving R is equal to 1 circle. So ultimately from three expression, now three questions I have told you, you can understand that, see, this question was causal, 2 to the power n. Now I will tell you, from in green color you say this signal or impulse response is causal or not causal. So it is causal because it is existing, the ROC is outward. But it is stable or non-stable? It is non-stable. It is non-stable because it is not involving R is equal to 1. And now we'll see this type of question. This question was, see, this is u of n, means it is going outward, so it is a causal signal. And is it involving the R is equal to 1 circle? Yes, it is involving R is equal to 1, so it is a stable signal. It is causal and stable. Now we'll see our next type of question which we have seen here. This signal is causal or not? So I'll tell you it is not causal, non-causal. And is it stable? So it is stable. So now you understood, maybe you have understood that what I wanted to tell you by taking different examples. I wanted to tell you how we can judge causal and non-causal, and stable and non-stable from time domain and from ROC value. Okay. Now we'll see some type of signal which are two-sided. Okay, so we'll take some example. Let's suppose your example is 3 to the power n, u of n is there, and then minus 5 to the power n, u of n is there. Okay, fine. And then we'll see actually this is, both signals are right sided only, and we need to see how ROC is formed by considering its poles. So see, its Z transform will be Z by Z minus 3, and here Z by Z minus of minus, so plus 5 will be there. Okay. Okay, so see, now what you will get to understand, its ROC, its both ROC can be seen, means complete ROC of a signal. This is unit circle, and your pole is in Z is equal to 3. Okay, at Z is equal to 3, pole is there, so it is outside the circle. It is Z is equal to 3, maybe for Z is equal to 3, we'll plot Z is equal to 3. Actually mod Z is equal to 3, है ना? This is its ROC, this is its ROC, mod Z is greater than minus 5 is there. Okay, in Z transform, see, actually it is mod value only, so we'll consider like, see, it will be mod Z is greater than 5 only, because this is mod value, and mod value we are considering. So your Z is equal to 5 circle is like this. Let's suppose this is Z is equal to 5 circle, this is Z is equal to 3 circle, and this is Z is equal to 1 circle. So now see, this, according to this, the ROC should be outward, but as you know that ROC cannot, I have told you this is in Laplace transform chapter also, ROC cannot include any poles. ROC cannot include any poles. This is very important thing. ROC cannot include any poles. Rather it will be bounded by the poles. It will be bounded by the poles. So considering this term, will see Z is greater than 3, means if it is ROC is like this, then it will consider Z is equal to 5 also. So, and ROC cannot include any poles. So ultimately, and for Z is equal to 5 poles also, means this Z plus 1 5, or you can say Z is equal to 5, this ROC will be also outward because u of n is there, outward. So ultimately final ROC can be formed by saying like this. Okay, final ROC can be formed by like this. So ultimately what you can say by this question, what you understood, that overall it is causal. Yeah, it is causal. Is it stable? It is non-stable signal, non-stable, because it is not involving j is equal to 1, z is equal to 1. It is not involving, so we cannot say it is a stable, or we cannot say it is integrable. It is non absolutely not integrable signal, है ना, combination of this. Okay, so see, now you understood that right-sided signal, ROC, how will form when two or more poles are there and all are right-sided. So final ROC will be after right outward after the greatest pole, which is greatest, z is equal to 5. So whenever we'll make ROC outward, we'll see and all are if outward right-sided only. Okay, now we'll see one more question and we'll try to understand. See, one more question is there. Let's suppose minus 2 to the power n u of minus n minus 1 will be there, and minus 1 to the power n u of minus n minus 1 will be there. You need to find its z transform, and you need to check its ROC, that where its ROC will be formed. So see, this z transform can be formed. See, you know that u of minus n minus 1, u of minus n minus 1 will be z of z minus 1. See, u of minus n minus 1 z transform will be z minus 1, है ना. ROC is z is less than 1. So minus 2 to the power n u of n. So it will be like, see, minus z by z minus 2. Okay, okay, and the value will be z is less than 2. Okay, 1 minute, I think this is there. Okay, this is there. So okay, fine, you this is 2 to the power minus 2 to the power n u of minus n minus 1 z transform is like this. So now where will this portion is solved, this portion can be written as, see, minus will be there. Let's suppose minus is there, minus 1 to the power n u of minus n minus 1 will be there. So its z transform will be z plus 1 will be there, and ROC will be mod z is less than 1. So we'll plot final ROC. R is equal to 1 circle is there. Now see, for this one z is less than 2. So this is mod z is equal to 2. So it is less than 2. So it should be inward, and this says that mod z is less than 1. So it is more inward. So where we will draw? If we will draw this side from z is equal to 2, then this portion, this pole will come inside it, and ROC cannot include any pole. That is why we'll plot from this point. Okay, this point only. This is your ROC value. So ultimately final ROC is left sided, because means not left sided, we can say inward. Okay, and inward is there, and where is inward means the smallest pole value inward to that, है ना? So now see, final from these two question, I just wanted to tell you that whenever combination of signals are there and all are right sided, so the ROC value will always be outward of the greatest pole. And whenever all signal combinations are left sided, means inward or left sided only, you can say the signals are left sided, then its ROC will be inward, and in which inward means the least pole inward. Okay, so from these two questions I wanted to tell you like this. Now I will tell you one more question. We'll see one more question and we'll try to understand this property. Let's suppose your f of n will be half n u of n is there. Okay, half n u n is there, and we'll see minus 5 by 6 n u of minus n minus 1 will be there. Okay, okay, and now let's suppose plus 3 by 4 question is going on. N u of n is there, and let's suppose minus 7 by 8 to the power n u of minus n minus 1 will be there. Okay, now you need to solve this question. You need to take it out its z transform, and you need to check ROC. So see, this term z transform is z by z minus half, and mod z should be greater than half, है ना, minus 5 by 6 to the power n u of minus n minus 1. So here it will come plus z by z minus 5 by 6, because minus u of minus n minus 1 will be z by z minus 1, so it will be like this, and this z is should be less than 5 by 6. Here the value is for this value, its value is z by z minus 3 by 4, and the value should be z is greater than 3 by 4, and this value represent z by z minus 7 by 8, and its value should be z is less than 7 by 8. Okay, now you have the combination of many signal. This is f of z. Now we will draw a final ROC. Like this, ROC will be there, unit circle will be there. This is mod z is equal to 1. Now we'll see this value is mod z should be greater than, when two right sided signal are there. See, two right sided are there, so I told you ROC will be outward from the greatest pole, so 3 by 4 will be there. So let's suppose this is your z is equal to 3 by 4. Let's suppose this is your z is equal to 3 by 4. Okay, now when two signals are left sided, so the ROC will be inward, and for the least pole, so 5 by 6 will be there and 7 by 8 will be there. So 5 by 6 is smaller and 7 by 8 is bigger. So obviously 5 by 6 circle is there. So okay, I have made it like this. I'll rub it. It is all rubbed. Okay, I will make you new. So see, this is your unit circle. Let's suppose this is your unit circle. Okay, and your 3 by 4 3 by 4 circle is like this. 3 by 4 circle is like this. Z is equal to 3 by 4, है ना, and Z is equal to 5 by 6. 5 by 6 is like this. Z is equal to, let's suppose this is Z is equal to 5 by 6, है ना. Z is equal to 5 by 6 will be there. This is Z is equal to 3 by 4 is equal to there. So what is your ROC? It should be greater than 3 by 4, and it should be less than 5 by 6. So this will be formed, this will be formed, this will be formed. But can you tell me, is it this whole portion, this whole question was stable or unstable? So you can tell me, sir, is it is not involving at all. It is not involving at all the z is equal to 1. So combination of all is not involving z is equal to 1. So it is not stable. It is not stable. It is not absolutely integrable. If you see all the value, you will see that it is not absolutely integrable. Combination of all, and it is causal. So see, we cannot say that it is a causal, because two portions are ROC is outward, two are inward. So we can say that it is a two-sided signal. Two-sided. It is two-sided, and we can say that it is non-causal. It is non-causal because it is inward also. है ना? It is inward also. If it is outward only, we can say that it is causal, and we can say that it is not absolutely integrable. Not absolutely integrable. Okay, fine. So now you can understand. See, from this question, I just wanted to tell you that how ROC is formed in the circular strip. है ना? Concentric circles are there, and we have formed a circular strip in between, because two types of signal are there, right sided also, left sided also. So, and there is a convergence in that. That is why we have taken like this. Some signals are like this. If maybe this z is equal to is greater than half is there, or z is these all are maybe left hand sided, and these all are, see, if this is now it is right sided. If it is left sided, if it is left sided and this is right sided, this is right sided, if question is like that, then what you will understand that some signals are inside and some are outside. There will be no common ROC, and wherever no common ROC is there, there Z transform is not defined only. I have told you in Laplace also. Here also I am telling you that wherever see, I will write here, wherever no common ROC, wherever no common ROC is present, is present, then Z transform is not defined. ND means not defined. So from this question you can understand that what I wanted to tell you from this question. Now we'll see some Z transform for some finite amplitude, finite time signal, है ना? So we'll see some of the question how to calculate Z transform for, if you have been given f of n is equal to, let's suppose 1 2 3, this value is given, है ना? And your n is equal to 0 for this signal. Now you calculate, you are asked to calculate Z transform for this type of signal. How you will calculate? One method is simple method, है ना? One method is simple method. See, if you need to calculate f of z, so ultimately what is the formula? N is equal to minus infinite to infinite. F of n will be there, and z to the power minus n will be there. Okay. Condition for existence, these all are only 3 values are there, so it is absolutely integrable. So it is, condition is satisfied. Okay. So what we can write? We can write absolutely here. If we have to expand it, what we can expand? f0 value z to the power 0, है ना? And then f of 1 value will be there, z to the power minus 1, plus f of 2 value will be there, z to the power minus 2, and so on it will go. And for left sided also it will go like this. If I'll remove it, okay, I will tell you. F of minus 1 will be there, z to the power 1 will be there, plus f of minus 2 will be there, z to the power 2 value will be there, and so on it will go on like this. This is actually the full expansion of this Z transform formula. Now see, ultimately what I wanted to tell you, f of n into z to the power minus n. F of n, you know now, for n is equal to 0, what is f of n? For n is equal to 1, what is f of 1? So for f of 0 is whatever in for this question, if we will consider, f of 0 is nothing but 1, and z to the power 0 is nothing but 1 only. But here f1 value will be 2, and z minus 1 will be there, plus 3, z minus 2 will be there, and any other signal will come? No, because all values are 0 only, so whatever is 0 only. Here any value is there, f of minus 1, no values is there, so it will be 0 only, so anything multiplied by 0 is 0, so like this. So ultimately your f of z value will be like this. This is the Z transform for this type of signal. Very easy to calculate. See, I told you by this method, I will tell you very shortcut only. See, by seeing this type of signal, wherever n is equal to 0, you need to write, see, first value you will write like 1, then whatever value will be there, 2, z to the power minus 1, 3, z to the power minus 2, and so on it will go on like this. So it is very easy to calculate from directly to it. No need to go further and do this. For explaining only I was telling you like this. But the ROC value, where is ROC? That is more important for us. So see, considering this f of z, ROC value can be, see, if you take for z is equal to minus, see, minus 1 is there, okay, z minus 1 is there, z minus 2 is there, z is equal to nothing but r e to the power j omega, है ना? Z is nothing but r is equal to r e to the power j omega. So ultimately what we can say that what we are searching, ROC is nothing but mod of z value, है ना? Mod of z value, that is means r. So here if you will see, f of z value will be there, will put here r e to the power minus j, r to the power j omega to the power minus 1. Wherever, see, where this expression cannot happen, this expression, or I'll write here, see, f of z is there, I will write r e to the power j omega, because z can be represented as this. We can write 1 plus 2 r e to the power j omega minus 1 है ना, plus 3 r e to the power j omega minus 2, like this है ना. For your better understanding, but z transform is like this only. So I am telling you that, see, for which value of r this expression cannot happen, this expression will not hold. So see, r to the power minus 1 is there, 1 plus 2 r to the power minus 1 is there, e to the power minus j omega, no issue. 3 r to the power minus 2 is there, e to the power minus 2 j omega. So see what I wanted to tell you, r to the power minus 1, just look at this, r to the power minus 2. If you will take r, है ना, greater than 1, or let it be not r, see, r to the power minus 1 is there, means r 1 by r, है ना. If r is equal to 0, let's suppose r is equal to 0, what will happen? 1 by 0 is infinite, so this series will exist? No. So what will happen? This ROC is, this expression is good to hold, but it will not hold except, means it will not, it will hold except for r is equal to 0. For r is equal to 0, this will not hold, but this ROC will be entire z plane except r is equal to 0. Now I think by explaining this much you should understand this point which I wanted to tell you. In Hindi if I tell you, see, देखिए f of n आपको दिया हुआ है क्वेश्चन में, और आपको f of z निकालना है. बहुत आसान तरीके से हम निकाल सकते हैं f of z, लेकिन हमको ROC को कंसीडर करना है. ROC क्या है? ROC तो देखिए इसका बेसिकली ये एब्सोल्युटली इंटीग्रेबल है, तो इसका तो एंटायर एस प्लेन होना चाहिए साफ साफ. लेकिन देखिए अगर आप इसको एक्सपांड करते हैं तो आपको पता चलता है कि एग्जैक्टली फॉर r इज इक्वल टू 0 वैल्यू डजंट एग्जिस्ट. इसका मतलब ये है कि इसका ROC क्या होगा? एंटायर z प्लेन एक्सेप्ट फॉर r इज इक्वल टू 0. एक्सेप्ट r इज इक्वल टू 0, it will be entire z plane. Okay, we'll see one more question and we'll try to understand this more property. See, you have been given a question. Let's suppose f of n is given, and you have been asked, it is given 1 2 3, and now here n is equal to 0 point is there, है ना. Now you will calculate z transform, है ना. Z transform you need to calculate. Question is there. Okay, so see, we'll see the solution. See, here directly can I will do it. F of z is there, so this is n is equal to 0, so this value will be there, only 2 value will be there, plus here this is n is equal to 1, so z to the power minus 1 will come, so 3 z minus 1 will here, and here it is in n is equal to minus 1, so we'll keep 1 into z to the power 1 will be there. Okay, so now value came z plus 2 plus 3 z inverse. This is the f of z, but its ROC is ROC. See, finite number of signals are there, absolutely integrable is there, so it will be entire z plane, but is it entire z plane, or some values are infinite, some values are left? So see, whenever mod z is equal to 0, will it be integrable or added? No, it will go for infinite. So this mod z is equal to 0, this condition is also not satisfied. If mod z is equal to infinite, for this value it will go for infinite, so this value is also not satisfied. So we can write that its ROC is entire z plane except r is equal to 0 and r is equal to infinite circle. Okay, so this question you can understand all the thing. Now we'll see one more question. And we'll try to understand where when Z transform is possible and when Z transform is not possible. So let's suppose your signal is given f of n equal to 1. It means that for every value, this is 1 only. This is 1 only. For every value, this is 1 only. So is it possible to find Z transform? See, if it is having one value for every n value, so it is not absolutely integrable. So we can find. Let's check. Let's check. So see, 1 can be written as u of n plus u of minus n minus 1. It can be written u of n Z transform is nothing but Z by Z minus 1, है ना? Z by Z minus 1, and here it is minus Z by Z minus 1, but its ROC is greater than 1, its ROC is less than 1, है ना? But see, the values get cancelled and the value is 0. Okay, ultimately you can see also from ROC value also, if this is your unit circle, this ROC is tending towards inside, sorry, outside. So this ROC is outside, okay, and this ROC is inside, this ROC is inside. So there is no common ROC, no common ROC, and whenever there is no common ROC, then Z transform is not defined. And here we can see the values also, that its value is 0, so Z transform is 0. It is not defined at all, it is not defined. Okay, so now you have understood maybe. Now we'll see one more question. We'll see one more question. Let's suppose f of n is a to the power mod n. A to the power mod n value is there. Now see, it's z a of to the power mod n can be written as a to the power n, u of n can be written, and it can be written a to the power minus n, u of minus n minus 1 can be written. Yeah, u of minus n minus 1 can be written. Now see what we need to do. Z transform. Okay, Z transform is Z by Z minus A will be there, and its mod Z will be greater than A, because u of n is there, and plus it will be minus n u of so it will be minus Z by Z minus A will be there, Z minus A will be there, and no, I think a to the minus n is there, na? So 1 by a is there, Z minus 1 by a is there, and its Z value is less than 1 by a. So ultimately, you can see it's Z transform. First of all, you'll see Z transform, then only you'll do. Otherwise, if it is not defined, then why to solve it? So let's do it. This is your Z transform. R is equal to 1 circle. Let's suppose your ROC. Up now A is something you need to assume. So mod Z will be there. It is greater than A. It is greater than A. It is greater than A, and it is less than. It is mod Z is less than 1 by A value. So if at all your A value will be greater than 1. If A value will be greater than 1, then will it be possible? 1 by, let's suppose A is equal to 2. Let's suppose A is equal to 2. So what will happen? 1 by 2 is, so what will happen? Mod Z is less than half. Mod Z is less than half means half circle is there, and mod Z means invert circle will be there, invert ROC, and mod Z is greater than 2 means outward. So there will be no common ROC. For this I will tell you, and this value is there. This is Z is equal to half, so it will make here, and it will be Z is equal to 2, so it will be there. Z is greater than 2. So there is no common ROC, so will not use this value. If A is less than 1, so let's suppose A is equal to half is there. So what will be there? Mod Z will be equal to, it will be 1 by half means 2, and it will be 1 by 2. So for this case, if your Z is equal to 1 is there, so the case may be mod Z is less than half, less than 2. So maybe this is your Z is equal to 2 circle, so it will be invert, and it is greater than half. So let's, it is a half circle, so it is greater than half, it is greater than half, and it is less than 2. So value will be like this. Okay, ultimately this is your z is equal to half and this is equal to z is equal to 2. So there is a common ROC, there is a common ROC, and so uh, your z transform is defined, z transform is defined. So this value can be considered, this value can be considered, okay, this value can be considered. So maybe okay, no, not this value, sorry, this value for a is less than 1, this value. So ultimately for a is less than 1, this value can be considered and your ROC is common. So in questions, you will be asked the expression, and you will be asked, you may be asked that options are there for which value of a z transform is possible, and you need to check where common ROC is formed, and then you can solve it. Okay, so acha, if you'll be asked that for this type of signal, whether it's DTFT is possible, whether it's DTFT is possible. So you can see that its common ROC is greater than half and less than 2, है ना, less than 2. So it is involving ROC, I'll not it, ROC is including your R is equal to 1 circle, that is unit circle, है ना. So therefore for f of n is equal to a to the power n, a to the power n, DTFT is possible, है ना. Or you can say that a to the power n is possible means is stable, is absolutely integrable for this value, for a is less than 1, है ना. जब हम a is less than 1 कंसीडर करेंगे तभी ये सब पॉसिबल है, अदरवाइज पॉसिबल नहीं है. आपने देखा है when we have kept a is greater than 1, then common ROC was not forming, so then DTFT is not possible, or nor it is a stable. But for a is less than 1 only ये सब चीज पॉसिबल है ना, DTFT पॉसिबल है. So okay, सो हम क्या कर रहे थे, DTFT इज पॉसिबल, ओके, फॉर दिस वैल्यू. और अगर आपको DTFT की वैल्यू चाहिए तो आप क्या कर सकते हैं, यहाँ पे वैल्यू को पुटअप कर सकते हैं. आप f e टू द पावर j ओमेगा लिख सकते हैं, f e टू द पावर j ओमेगा. वहाँ पे लिखा था क्या वैल्यू, z बाय z माइनस a, तो यहाँ पे लिख सकते हैं e टू द पावर j ओमेगा बाय e टू द पावर j ओमेगा माइनस a, है ना. और ऊपर में क्या लिखा था, यार z बाय z माइनस 1 बाय a, है ना. तो यहाँ पे लिख लेते हैं e टू द पावर j ओमेगा, है ना, बाय e टू द पावर j ओमेगा माइनस 1 बाय a, है ना. और बस दिस इज द वैल्यू. तो सी it is very easy to calculate ROC for Z transform, for DT, how to calculate DTFT also very easy. Till now I think all concepts you must know and you must remember. So in next lecture we'll see some more property like linearity property, time reversal property, multiplication by n, and convolution property, time shifting, and then we'll go for time integration, time differentiation, and then we'll go for initial and final value theorem. So maybe if possible we'll complete in the next lecture, or it may take 2 lectures also to complete. So we'll try to complete it as soon as possible with more detailed analysis, everything more. So for this lecture this much only. We'll meet in the next lecture. If you have liked the video, please hit the like button, share it with the needy students, and if you have not subscribed, please subscribe the channel as soon as possible. And okay, Jai Hind, Jai Bharat.